In part B, it says that a triangle is formed when a tangent at the curve at B, the normal to the curve at B, and the x-axis. We have to find the area of the triangle. Now, if you go back to the curve, it means that, let's say if you make a rough tangent from at point B and a normal at point B, so it will form a triangle with the x-axis. Now we already have the height of this triangle. If we are able to find the x-coordinate of the tangent at which it crosses the x-axis and the x-coordinate at which the normal crosses the x-axis, we'll add the two values to get the base and then use the triangle formula half base into height to find the area of the triangle. Now to find this point, first we need the equation of the tangent and the normal. So we have the equation as y equals to, so the equation was y equals to 4 upon 2x minus 1 whole squared. So we'll write y equals to 4 upon 2x minus 1 whole squared. Finding the dy dx, so first we'll write it as 4 into 2x minus 1 to the power minus 2. So the dy dx will be minus 2 into 4, which is minus 8 into 2x minus 1. This will become a minus 3 and we'll multiply it by the derivative of 2x minus 1, which is positive 2. So this will become minus 16 upon 2x minus 1 whole cube. Now at B, the x value was given, which was equals to 3 upon 2. So substituting x equals to 3 upon 2 into this equation, we'll get minus 16 upon 2 into 3 upon 2 minus 1 whole cube. So cancelling 2 and 2, we'll get 3 minus 1, which is 2. 2 cube is 8. So we'll get minus 16 upon 8. So minus 2, this is the gradient of the tangent, which means that the gradient of the normal, so if the gradient of the tangent is minus 2, the gradient of the normal will be the negative reciprocal, which is positive 1 upon 2. Now forming the equation for the tangent and the normal. So for the tangent, we'll use y minus y1. So let's look at the point B, that was 3 upon 2 comma 1. So the point we had was 3 upon 2 comma 1 and the gradient of the tangent is minus 2. So the equation will be y minus 1 is equals to minus 2 into x minus 3 upon 2. And for the normal, the equation will be y minus 1 is equals to 1 upon 2 into x minus 3 upon 2. Now, when they're crossing the x-axis, we know that the y value will be 0. So putting y equals to 0, we get minus 1 is equals to minus 2x plus multiplying 2 by 3 upon 2, we'll get a plus 6 upon 2, which is a plus 3. So minus 2x will be is equals to minus 4 and x will be equals to 2. So the tangent is crossing the x-axis at x equals to 2. Taking y 0 over here, we'll get minus 1 upon 2 is equals to half x minus 3 upon 4. So taking 3 upon 4 on the other side, we'll get 1 upon 2x is equals to negative 1 plus 3 upon 4. Simplifying this, we'll get 1 upon 2x is equals to minus 4 plus 3 upon 4, which is equals to minus 1 upon 4. And then multiplying 2 on the other side, we'll get minus 2 upon 4, which is equals to minus 1 upon 2. So the normal is crossing the x-axis at minus 1 upon 2. Now, if we come back to the diagram, we can say that this point is negative 1 upon 2 and this point is positive 2. So the difference between these 2 points will be 2.5. As we are looking to find the area, the base will be 2.5 and the height was the y value. So the y value was positive 1. So to find the area, it will be 1 upon 2 into 2.5 into 1. So 2.5 divided by 2, that will be equals to 5 upon 4. So the area formed by the tangent, the normal, the x-axis will be equals to 5 upon 4. We can write it as 25 upon 20, which will become 5 upon 4, or we can just simply substitute this in the calculator to get the area.